So this video is on quadratic functions in vertex form. And before I begin talking about vertex form, I just want to do a quick review of some vocabulary when we're talking about quadratic functions. So as you begin your notes, you can kind of draw a similar graph to the one I drew in your notes, and you should have graph paper, so you can do it. You should do it on graph paper. Please pay attention to where I plotted my points. Those are specific points. And you see the shape of this curve is called a parabola. So any U-shaped quadratic curve is going to be called a parabola. So we say parabola is the graph of a quadratic function. That's simple. And we also kind of think of it as like a U shape. And with that U shape, it actually is symmetrical, right? So we have this dotted line I drew in red here, right? This is like the line that divides our parabola in half, and that is called the axis of symmetry, okay? So the axis of symmetry is a line that divides the parabola into two mirror images. And the last vocabulary word I'm going to go over is the vertex. The vertex is that center point on your parabola, that point in the middle. Here it's on the bottom, but sometimes you'll have a parabola that's facing downward, and then that point could be on the top. So the way we'll define the vertex is the point at which the function or the parabola reaches a max or min value. Sorry for my cramped writing, I'm running out of space. Okay, so the idea is that center point on the graph will always either be the minimum when the parabola is facing up, or it could be a maximum if the parabola is facing down. And now I'm just going to add to our picture to kind of fill in some of those key vocabulary words. So first of all, I'm going to kind of label my axis of symmetry. So I'm going to write axis of symmetry. I'm just going to abbreviate symmetry with a SYM. And then I'm kind of like drawing a little arrow over there. So that's my axis of symmetry. Right here we have the vertex. That point in the middle. And then I'm also just because it's here on our graph, we also have a y-intercept. And just one more notational note, we refer to the vertex as the ordered pair h comma k. So h and k are the variables used to describe the vertex. And then if you notice, the axis of symmetry goes straight through the vertex, right? And so since that's a vertical line, it's always going to be x equals some number. And the number is what's the value of x that the vertical line is passing through. Well, that's the x value of the vertex. And we're calling the vertex x value h. So we can say for our axis of symmetry will always be x equals that h value of the vertex. So in the next part of our notes, we're going to look at how the values of a, h, and k in the vertex form of a quadratic function transform the graph, or how does it change the position of the graph on the coordinate plane? And again, right above this, I just want to make sure we have this in our notes. This is what's called vertex form. Okay, so first let's think about the A value, and I'm going to kind of draw an arrow over to here where we're going to kind of write down what does A do to our graph. A actually does a couple of different things. The first thing, and you saw this in the exploration we did in class, is A could make the graph skinnier, and we call that a vertical stretch. And to kind of give us a way to remember it, that means that it's skinnier or narrower. And then in order for the graph to get narrower or skinnier, then the absolute value of A needs to be greater than 1. What I mean by the absolute value of A is that we could have like 2 or 3 or 4. Those are all positive numbers greater than 1. But also like -3, if I take the absolute value, I get 3. So a -3 is still going to make the graph skinnier because the absolute value of -3 is greater than 1. Then the second thing that could happen is your graph could get wider, and that's called a vertical shrink. So vertical shrink, your graph is getting wider. And in the exploration, you saw that happen when you graphed 1/2 x squared, right? So then the idea is that A needs to be some fraction less than 1, but it could also be a negative fraction, right? So again, I'm going to say that the absolute value of A should be less than 1, and that kind of limits me to everything between 1 and -1 as fractions. And any of those should make our graph wider. Now, there's one last thing that A can do to your graph, which is it could flip it over the x-axis, right? So we could have what's called, remember from geometry, a reflection. And we're going to see that we're going to see a flip over the x-axis. And this happens whenever A is negative. So I don't need the absolute value bars when I define this range. It says whenever A is less than 0, which means it's negative, we're going to have a flip over the x-axis or a reflection. Okay, so that's everything having to do with A, kind of make like a divider, so we kind of put all this stuff together in a box. So now let's think about H. Okay, and H ends up being what's called the horizontal shift. It moves the graph to the left or to the right. And what you should have noticed in your exploration from class when you were graphing, when you added a number inside of the parentheses to x, it actually moved the graph left. So if you had like a plus a number, then you're going to shift left, which is kind of like the opposite of what you would think. And then if you have minus a number, it's going to shift right. And that's all that really H can do, is just move the whole thing right or move the whole thing left. And you just have to remember that it's the opposite way of what you might think. Even though right is the positive direction on the x-axis, the minus a number is what shifts it right. Okay, so then the last value is K. And K is going to move our graph up and down, so we call that a vertical shift. And here the signs follow what you would think they would. So if you add something, if you add a number, it's going to go up. And if you subtract something, it's going to go down. Okay, so let's take a look at an example. I have a function in vertex form, f of x is equal to negative parentheses x minus 1 squared plus 3. So I'd like to be able to get some information from this function. And in vertex form, I can get a couple of pieces of information very easily. The first thing I can easily identify is the vertex. So in this case, the vertex, which is your h comma k, right? So remember that the form looks like a x minus h squared plus k. Okay, so if I want to pull out the h and the k value to be my vertex, well, for my k, it's pretty straightforward. I see a plus 3, that is exactly k. But the h is a little bit different because you'll notice that there actually is a minus sign built into the equation, right? So since that minus sign is there, h is actually the value without the minus sign, or it's the opposite value of what you see, the opposite sign of what you see. So if I see a minus 1, that's actually moving my graph to the right, which means the vertex will be at a positive 1 value for x. So even though I see a negative 1 there, I'm putting a positive 1. If I saw a plus 1, it would make me put a negative 1 in my vertex, okay? So the vertex is 1 comma 3. I can also write an equation for the axis of symmetry, which is just x equals the x value of the vertex. It's going to be that vertical line, x equals 1. Okay? The last thing I can easily do is describe the transformations that I think have taken place from x squared. From x squared. Okay, so in this one, there are 3 different things that I have to think about. I have to think about the a, the h, and the k. So in this situation, my a value is negative. It's just a negative 1. So it isn't greater than 1 or less than 1, so it means that its width is the same as x squared, but it's negative, so it's flipped over the x-axis, right? So we can say it's reflected over the x-axis. And we can say that because a is negative. The vertex is telling us how we shifted vertically and horizontally, right? So we did a shift to the right of 1. I'll just write the number 1. And we also shifted up by 3. Right, so it's the opposite sign for the 1, so it's just going to the right, and then plus 3 means a shift up 3. Okay, so I have a pretty good idea of where this graph is on a coordinate plane right now. And that's going to help us because the next thing we're going to think about doing in class is graphing these types of functions.